All right, week one, your first step into calculus. So, what we are working on this week is going to be this idea called limits. And so, within the sections of the book, that is 2.2 through 2.6, I've also highlighted the sections in the weekly success guide that you can read at Paul's online math notes. There's also Khan Academy has a good section on it as well. But honestly, reading the textbook is going to be really helpful. The textbook is really well written. It seems weird to have to read math. Reading math is a little slower than you would expect. You can't read it like you'd read a novel, but if you do that and you look at the examples in there, that will help a lot. What I'm going to do right now is to give you the general idea of what limits are. So rather than focusing on the mechanics of how to evaluate limits or anything like that, I'm just going to talk about the concept. So with limits, the idea is essentially this. When you have a mathematical function or something, there is a difference between what it does and what you expect it to do, what it should do. So everything you've done up to this point in mathematics has been, what does this function do? Right, so if you were looking at a parabola, right, when you were taking algebra, you said, where is the vertex, right? Where is it? If you were looking at different function values, like say you remember that stuff where you had like f of 4, so you'd have f of parentheses 4 and then a closed parentheses, and so that'd be your function f evaluated at the value 4. You'd look at 4 on the x-axis and then go up to wherever the function is on the y-axis, and that y value would be your answer. That would be where the function is. A limit is where the function should be. And so the way I like to imagine it is something like this, right? If you were approaching, let's say you had a GPS, right, in your car, and you're driving your car and you're approaching an intersection, right, and somebody is watching that GPS. Let's say your mom, because she's worried about you and not make it creepy like some kind of government spy or something like that. So your mom's watching you, she's just making sure you're okay, right? And you're approaching this intersection and the GPS signal goes out for a couple seconds. Now you, at the intersection, right, you get up to the light and you turn right, and then you keep going. What your mom sees on that GPS is you approach the intersection, it cuts out, and then you're suddenly going down a street to the right. Now, your mom can probably figure out that at that intersection, you turned right. She doesn't know that for sure, but that's what should have happened. That is a limit, right? Making that assumption, this is what the car should have done in order for it to approach this way and then leave that way. I'm not good with the camera. Leave that way, right? That assumption is what a limit is, except instead of cars, we're talking about functions. So functions start to approach certain values, and anytime we talk about a function doing something or where a function is, we talk about the x-axis. So our x-axis is kind of like the where, and the y is the values. So as we're approaching something on the x-axis from either side, right, rather than wondering what happens at that point, we're going to say, what should happen at that point? Right? If our function starts to go like this and then starts to go like this, even if we don't know what happens here in the middle, right, well, we can figure out it probably should connect like that. And so we should expect the function to be about here. And so that's the difference between a limit and a function value. And so we can do this for any kind of function, for any value of x. And the way we say it is the limit as x approaches whatever number it is. So its limit as x approaches 3, right? And that would be, what should the function do at the value x equals 3? What should the y value be at x equals 3? Not what is it, but what should it be? And so this is essentially what a limit is, and this is what the entirety of calculus is based on. And I'm not kidding when I say that. That is not one of these like weird teacher over exaggerations where I try and make something sound exciting when it's really not, so I have to make it sound really important. Like, no, this is actually what the entirety of calculus is based on, is this idea of a limit. And the way we're going to view this is by looking at, well, basically limits as things get very small and limits as things get very large. Now, we don't have to worry about that yet. That's next week U's problem, is to worry about what happens when things get very small. And we'll talk about that in a concept called derivatives later. For now, we just want to get comfortable with this idea of a limit and how it differs from the things we've done in the past. So what we're going to do is we're just going to take a look at kind of what this limit is, and that's 2.2. And so you're going to be given some examples where you literally plug in values as your x approaches some number. So if we go back to the x approaches 3 example, I might plug into my function 2.5, 2.9, 2.99, 2.999, 2.999, right, all the way as far as I want to go, and see what it looks like it's approaching. And then I do it from the other side too, right? So I plug in 3.5, 3.1, 3.01, 3.001, 3.0001, right? And I see from both sides kind of what's happening and what they're approaching. And I can use that to make an assumption about what is happening at this point, right? Even if I don't know what's happening there, if I see where they're headed, then I can make an assumption about that. So that's what you're going to do in 2.2. 2.3 is going to be just more of the kind of how do we actually evaluate the thing out. And then 2.5 deals with the concept of continuity, which is going to be important in evaluating limits. Continuity is basically, and you've seen it before, right? The idea of continuous is basically, can you draw the function, right? If you have your pencil and you're drawing the function, if you can draw the entire function without picking up your pencil, it's continuous. Simple as that. Now, mathematically, what that means is there are no discontinuities, meaning there's no holes where I have to pick up my pencil and just move it slightly. There's nothing where it goes off to infinity, right? So I don't have a function that looks like this, right? And there's this vertical asymptote in the middle. That would be a discontinuity. And I don't have any weird skips where the function teleports. So I'm not going this way, and then the function goes this way, and then there's this weird teleport thing that happens where it goes, and then that way. So that deals with continuity, and then that will also help us evaluate limits. 2.6 deals with limits at infinity, and limits at infinity are basically going to be looking at what happens in those scenarios where I have a function that goes off to infinity. So let's say this point in the middle, I don't know, I've just been really digging 3 today for some reason. So let's say at x equals 3, the function does this. Well, if I want to talk about the limit, right, as x goes to 3, then I need some way to deal with the fact that this just goes off to infinity. So we'll talk a little bit about that. And then the other thing is what happens as actual x goes to infinity. So what does the function do as x gets larger and larger and larger and larger? Or reverse, as it goes to negative infinity, it gets smaller, 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 smaller. And so we can look at that, and that's what's called end behavior. Now, if you remember a thing from algebra called horizontal asymptotes, that is exactly limits at infinity. Right? That is, as x goes to 0, that is the end behavior of the function. That's kind of what the function does at the ends of the axis. And so that's just horizontal asymptotes. And so you'll learn about horizontal asymptotes and vertical asymptotes and how those relate to this thing called limits that we're learning now. And so we can take old things that we learned in algebra and reformulate them in a new way. The one thing I do want to mention is that we are skipping 2.4. That is a section on the precise definition of a limit. And so you'll see the definition of a limit, and it's kind of wishy-washy, at least from a mathematical perspective. There is a way to precisely define a limit, but it is not something I feel like we have time to cover and give adequate time to right now. So that is something where if you are interested in that, and you are interested in this concept, then you can talk to me and I'll be happy to explain what's going on and how it kind of relates to the definition that you'll learn in 2.2. Yeah, other than that, I'm not super worried about covering that right now. I think we have more important fish to fry. So that is essentially what a limit is. So like I said, take a moment and look over the weekly success guide. You're going to want to read the textbook. I know, I'm aware. Reading a math textbook sounds terrible. I promise it's okay. You'll be fine. Read the textbook. Right. Read the Paul's online notes. I think those are a very good summary of this. Now, they are organized a little differently, but that's okay. Right. Once you read the textbook, you'll learn what these concepts are called, and so you can look up the ones that you need a different explanation on or a better explanation on. And so you can look up those concepts and read those. As you're reading through, take notes like you would in class. Okay, so keep a notebook next to you as you're reading through. Write down important things. Write down definitions, right? Because you want to have that material there for you when you go to do the homework. You want to have it kind of nice and summarized rather than having to dig through the textbook to figure out what the answer is. Take a look at the examples. See if you can work out some of the examples. Right? See if you can look at the homework and see what examples look like the problems in the homework, and use that to help you learn how to do these different things. Because the problems on the quiz and the problems on the test are going to be very much like the problems in the homework and the problems in the examples. So make sure you can do the homework, and you'll be fine for the quizzes and the test. But I think that is everything that I need to tell you about limits right now. So again, 2.2, 2.3, skip 2.4, 2.5, and 2.6 are the things you want to look at this week. Go ahead and take a look at those. If you have any questions, please talk to me. Send me an email. Send me a message in Schoology, something like that. The only thing I wouldn't recommend is sending me a message in WebAssign, because for some reason I can't link it to my email, and so I never see it. So don't send me a message there. Send me a message instead on Schoology or through email, and I'll be happy to help out. If it seems like a monumental task at first, if it seems like you have no freaking clue what's going on at first, that's normal. That's okay. That's where we all start. And if you knew what was going on, you wouldn't need to be in this class. So it's going to be confusing at first. You're going to sit down and it's going to look like a bunch of gibberish. That's okay. Just read through it. You're going to read through it once, and it's going to make a little more sense. You're going to have some idea of what's going on. And then when you go to the online notes and the homework and you start to really dive into it, that's when you'll start to understand it. So don't worry if you don't understand it immediately, right? You'll get there, but don't get discouraged at first. So other than that, I will talk to y'all soon, at the very latest next week, and good luck.